The Messerschmitt Me-163 Comet is a rocket-powered interceptor aircraft primarily designed and produced by the German aircraft manufacturer Messerschmitt. It is the only operational rocket-powered fighter aircraft in history, as well as the first piloted aircraft of any type to exceed 1,000 km per hour in level flight. On September 1, 1941, the prototype performed its maiden flight, quickly demonstrating its unprecedented performance and the qualities of its design. Having been suitably impressed, German officials quickly enacted plans that aimed for the widespread introduction of this new point defense interceptors across Germany. During December 1941, work began on the upgraded Me-163B, which was optimized for large-scale production. In any operational sense, the Comet was a failure. Although it shot down 16 aircraft, mainly four-engine bombers, it did not warrant the effort put into the project. Due to fuel shortages late in the war, few went into combat, and it took an experienced pilot with excellent shooting skills to achieve kills. Ultimately, this point defense role that the Me-163 played would be taken over by the surface-to-air missile based on the Comet, the Messerschmitt Enzian. The Enzian was conceived as a ground-to-air flak weapon. Models E-1, E-2, and E-3 were the test and experimental airframes. All flight tests were carried out with the E-1. The E-4 was the production design using an improved rocket motor. The E-4 is a flying wing design of striking similarity to the Me-163. Its total weight is 1,800 kilograms, which includes the weight, 320 kilograms of the four assisted takeoff units. The warhead weight is 500 kilograms. The airframe is constructed of wood, having an overall length and span of 4 meters. It attained its velocity of 300 meters/sec with a main thrust unit delivering 2,000 kilograms, initially decreasing to 1,000 kilograms during the flight. Duration of power was 72 seconds, resulting in a vertical range of 16,000 meters and a horizontal range of 25,000 meters. The four assisted takeoff units deliver a combined thrust of 6,000 kilograms for 4 seconds, giving the missile an end speed of 24 meters/sec acceleration from a launch ramp 7 meters in length. The assisted takeoff units are jettisoned after 5 seconds. A standard 88mm gun carriage was adapted for use as a launching platform by the simple addition of 2 iron rails 6.8 meters long. A traverse of 360 degrees and a vertical firing arc from 0 to 85 degrees were obtained. Air launching of the device was routine, i.e., dropping free from underneath the parent aircraft flying in the direction of the target. For practical purposes, an elapsed time of 5 seconds is allowed between the triggering of the launching mechanism and the first control signal. The Enzian, as were practically all German guided missiles, was directed to the target vicinity by radio control. When the target approach was within the range of the homing device, the latter took charge of the missile's final run-in. Coincidence or line-of-sight navigation was used under favorable conditions. However, several methods were accepted for night or reduced visibility use. The Enzian E-4 airframe was a flying wing type having no horizontal stabilizer and a fixed vertical fin. Control was effected through trailing edge flaps which act together as elevators and differentially as ailerons. The airframe was designed to be built of wood due to metal shortages. However, provisions were made for conversion to metal stampings. The production process was to use hot plate gluing methods for fabricating a pressed or plywood material. By May 1944, 60 airframes were complete, awaiting their engines. In order to gain flight test data, they were fitted with radar units instead. A series of 38 flight tests commenced with generally favorable results, but the engine still lagged. Finally, Dr. Conrad, the designer of the engine of the Raintokter missile, was asked to modify his design for use in the Enzian. On consideration, it appeared this was a much better and cheaper solution anyway, and after January 1945 there were no plans to use the Walter design. The resulting E-4 version with the Conrad engine was considered the production version. Because of difficulties in perfecting the proximity fuse, an infrared homing system, Madrid, was proposed, allowing Enzian to be flown right to the target. However, the system was never actually developed beyond a test bench mock-up. On January 17, 1945, All development projects were cancelled by the Luftwaffe in order to concentrate all possible efforts on only two designs, the Messerschmitt Me 262 and the Heinkel He 162 jet fighters. Although this was the official story, many in the Nazi and Luftwaffe hierarchy had their own pet projects continue. That is why some Messerschmitt engineers continued some low-level work on the project, hoping it would be refunded, but by March it was clear the cancellation order would not be rescinded and all development efforts ceased. Only 2 Enzian missiles are known to have survived the war. One is on display at the Royal Air Force Museum Cosford and the other is in storage at the Australian War Memorial's Trelawney Resource Centre after being displayed for many years at the Royal Australian Air Force Museum. I hope you enjoyed this episode, and to make sure you don't miss my future work, please make sure you are subscribed to my channel and press the bell notification button. Thank you and see you in the next video.